Can anybody tell me the definition of machine? So machine
The
has a lot of
combination
uh-huh.
the combination parts combined together to carry out a certain function.
Hmm. That is a correct definition.
A machine is a device which make our work easier.
Machines are
So machines are a device that make our work easier and convenient
make work easier and convenient. Okay, that's
with
also
a
correct.
small force applied.
Yes, yes. They can convert a small force applied to a larger force, or they can convert your uh, rotational motion into different forms of motion. So for you, you cannot write this definition in exam. For exam, you have to write the definition that is given in your book. So I'll just write down the definition first, and then we'll understand what a machine is. The word machine does not have a very peculiar definition as force and work and all that, but we try to define it in English. If you have something, you know whether it is a machine or not. An air conditioner is a machine. A washing machine, of course, it is a machine. A book is not a machine, but you can use it as a machine. You can hold the book in your hand, and you can use it as a device which can transfer force, but it is not a machine. You can use it as a machine. So what do I mean when I say that? So a machine is a device by which we can overcome a large resistive force or load at some point by applying a relatively smaller effort or load or force just write force, effort or force at a convenient point and in a desired direction. Or by which we can obtain a gain in speed. So of course there will be machines which will be outside outside the boundary of this definition. But I will try to explain this by examples. So I'm going to talk about simple machines, not your washing machine or air conditioner, cooler. Those are complicated machines. We're going to talk about very simple machine. Suppose if you have to lift a load, means you're living in ancient times and you need to lift a load. This is suppose a roller or some round stone you have got, and you want to lift this big stone. So what you can do, you can apply a force in this direction. And the simple setup will help you apply a large amount of force on this rock. So here what we are doing, we can overcome a large resistive force or a load. This load is applying a force on this plank in the downward direction, on this plank in this downward direction. And you can overcome this resistive force by applying a relatively small force or your effort. So this is your effort and this is your load or resistive force. So this is the example of a simple machine. This is the example of a simple machine where you can convert your effort into overcoming a large resistive force or load. So first example is you can write, we are using the force to lifting a heavy load. So in the function, of simple machines, first thing that you can write is lifting of heavy load. For this, the example was here. Lifting a heavy load by applying less effort. So this type of machines are called force multipliers. They will multiply your force. And of course, they use the concept of torque. The torque remains the same, but here see the length is smaller. If the length is smaller, the force applied on this rock will be greater. Here the length is larger, so force, even if you apply a small force, the smaller length you make of this, the larger force you can apply. So first one is a force multiplier. Then we can use to change the point of application of effort. You can use this to change the point of application of effort. So, for example, if you have a fishing rod, then you have a round thing here which you can rotate with a handle over it. You can apply force over here, but you see that the string which is attached to it, it gets pulled. The string attached to it, it gets pulled. And suppose you have a fish here. So you cannot directly apply force on the fish. Of course, you can do it, but it's not suggested that you go in water while fishing. So you have to apply force on the fish. So here, the point of application of effort is changed. You don't have to apply a force at the fish directly. You can rotate this and this chain will propagate the effort into the rope or wire, which can pull the string and which can pull the fish. So a similar thing happens in your bicycle. In your bicycle, you are putting effort on the paddle. Effort is on paddle. But where is the effect? The effect is moving on the ground. Effect is moving on the ground, that is moving off the rear wheel, moving off the rear wheel. When you apply paddle, your rear wheel moves, not your front wheel. The front wheel moves because rear wheel is moving, and that's why you start going in the forward direction. You're applying the effort on paddle, and the effect of this is to that the bicycle starts moving in the forward direction because of the movement of the rear wheel. Then next is it can be used to change the direction of effort to a convenient direction. Change the direction of effort to a convenient direction. So suppose you have a pulley. A pulley is attached, let us say, above the well. Don't have pulley these days. In well, of course. In villages, they are still used to pull the bucket of water. So here, means you can directly pull the bucket from bottom to up. That is a difficult task. Pulling the rope directly up, pulling the bucket directly up is a difficult task. This is difficult. But pulling the rope in the downward direction, this is easier compared to pulling the bucket vertically upwards. So here, using this, this again, the pulley acts as a simple machine. It changes the direction of effort to a convenient direction. Then a simple machine can always also be used to obtain a gain in speed.
So can you please show the last point, please?
Yeah,
Just a minute, sir.
yeah.
Yes, sir. So you can.
Okay. To obtain fourth point, so fourth use of a machine, the fourth function of a machine is to obtain gain in speed. Or in other words, greater movement of load by smaller movement of effort. So this is one of the function of the gears in your wheels. So you must have seen the gear on the rear wheel is bigger. And gear on your paddle is smaller. This is rear wheel gear. This is gear near the paddle. This is known as the driver gear, and this is known as the driving gear or driven gear. So on the driver gear, you have to apply less effort. So you want to give lesser velocity to the driver gear or to the paddle, such that this rear wheel gear, it rotates by a larger amount. And that's what happens when you buy a bicycle which has multiple gears on it. So as you increase the speed, you put on to the smaller gears on this. When you increase the gear from 1 to 2 to 3, the size of the driver gear becomes smaller, and the size of the rear wheel gear, it becomes bigger when you increase the number of increase the speed of the bicycle. So by lesser movement of your feet, you can gain a higher speed. By less movement of feet, can get higher speed. Chains are attached like this. This is chain, which connects the driver and the driven gear. Any questions?
Sir,
No, sir.
can we say a shoe is a machine?
A shoe is a machine. Tell me how. Tell me how.
Acceleration or movement speed, because studs give us a better bounce.
Better bounce. It won't be called a machine. It does not give a better bounce. It just stores the energy that it has. Once you have jumped, it is not giving greater force. Huh?
Okay, sir.
So see here, two things are mainly happening. The force is changing or the speed is changing. So a machine can be used to either apply the force or they change the speed, but both cannot be happening.
Can you show? So can you please scroll up?
Yeah.
Yeah, yes, sir, just a minute.
Okay. So one thing you have to note, machine cannot be used both as a force multiplier and a velocity increaser. So a machine cannot be used simultaneously as a force multiplier as well as speed multiplier. It can only increase one thing at a time. Noted?
Yes, sir.
Yes, sir.
Okay. Now see, there are some technical terms in the related to a machine, and we'll take a simple machine and we'll try to define it. So a simple machine that we can take is a scissor or a, let us say, you want to apply a load here. You want to lift a load, let us say the block is kept here, rock is kept here. And this is your fulcrum. Fulcrum is something which helps you pivot the object, pivot the plank. And you can apply force over here, maybe by your hands or by your feet. This is your force or your effort. So, and this is your load. Rock will be resisting your motion or resisting your effort. So first definition that comes in the definition of machine is the load. So load is the resistive or the opposing force. When you start a bicycle, you always feel some resistance in the beginning. Later also there is resistance. There is continuous resistance, but in the beginning you feel the most resistance because you have to start your motion. So the resistive or opposing force to be overcome by a machine is called the load. And of course, if this is the load, then this is the effort. Second part of a simple machine is effort. The force applied on the machine to overcome the load is called the effort. Load is denoted by L and effort is denoted by E. This is definition of effort. And once we define load and effort, we can define mechanical advantage. Mechanical advantage is a technical term related to the simple machines. is the ratio of the load and effort. Ratio of the load to the effort is called the mechanical advantage. Mechanical advantage MA is equal to load upon effort. So suppose if I ask you the definition in the exam, in the test, beside writing the definition, you should also write this equation. That will have a good impact on the copy checker, the examiner. Okay, note this down. Since both of them have the same unit, the units get cancelled, and mechanical advantage has no unit. It is a unitless quantity. Note it down.
So written.
Okay. So sometimes effort means force is increased. Sometimes you need a machine to overcome a force, and sometimes you need to give it a speed. So mechanical advantage is used when you're using your effort to lift up a load. And there is another term known as the velocity ratio. This is used when you are using effort to increase the speed of the load. So velocity ratio, written as VR, defined as the ratio of the velocity. See, these are the terminologies. Once we start off with the functioning of the machines, all of these terminologies will be used. The ratio of the velocity of effort to the velocity of load. So here it is reversed. Earlier it was load upon effort. Here it is velocity of effort upon velocity of load. The ratio of the velocity of the effort to the velocity of the load is called the velocity ratio of machine. And write the formula: velocity ratio is equal to velocity of effort upon velocity of load. VR equals to velocity of effort upon velocity of load. So velocity is equal to distance into time. So we can also write this definition in terms of the distances moved. If dl is the distance traveled by the load, in the same time, and d is the distance moved by the effort in the same time, so we can write velocity of load that will be equal to VL, that is distance of load upon time taken. Similarly, we can write velocity of effort equals to VE, that is distance of effort upon time taken. Then the velocity ratio, that is written as VR will be equal to VE. Remember, effort upon load, not load upon effort. Effort upon load, that is distance of effort upon time divided by distance of load upon time. These two gets cancelled, and what you get is velocity ratio is distance upon effort upon distance traveled by load. Note this down.
Sir,
Yeah.
sir, I didn't understand what is the meaning of velocity of effort and velocity of load.
Mm, think of it like this: you are paddling a bicycle, so your feet are moving with some velocity in the downward direction.
Yes, sir.
And bicycle is moving ahead because the tire is moving, the back wheel is moving. So velocity of your effort is less than the velocity of the tire, speed of your bicycle.
So,
Yeah.
Okay, sir.
so what is DE and DL? What
DER
does
distance moved by this load and effort in the same time.
Okay, sir.
Hmm.
Okay, sir. Okay.
Note this down. So velocity ratio can be written in the new definition form. So velocity ratio is the ratio of displacement of effort to the displacement of load. This is the ratio of displacement of effort to the displacement of load. That's a new definition for it. So again, it is a ratio, so it has no unit. It is a unitless quantity. A unitless quantity. Note this down.
Sir, done.
Okay. So that will be all for today. Besides, if you complete all the worksheet and homework, if you already done it, or after completing it, you get some time, then start reading chapter 3, that is machines. Start reading it from your book. Give it a reading, a casual reading. No need to focus on memorizing everything. Just give it a casual reading. So that will be all for today. See you next class. If you have doubt, you can stay and ask.